Should get started here in a second. All right, and we are live. Good morning, everyone, or good afternoon, depending where you are. Good evening. Thanks so much for everyone who is already joining. For anyone who doesn't know what the focus of today is, we're going to be talking about Apache Iceberg and what is it? What is it exactly? For that, I've got two great experts here on said topic. So if you guys would like to give yourselves a quick background, a quick introduction, Alex, could you just start and then we can go from there?
Mm-hmm. Hey, everybody. My name is Alex Brissett. I'm a developer advocate at Dremio and co-author with Dipankar on the upcoming Apache Iceberg, the definitive guide. And also me and Dipankar have written lots of blogs on Iceberg and also host of podcasts such as Data Nation, WebDev 101. Me and Dipankar do a podcast called Select Star from Data Lake, and also our weekly broadcast at Dremio, which is Gnarly Data Waves. All of those which you can subscribe to on iTunes and Spotify, etc. Dipankar, go for it.
Hey everyone, good. Thank you so much, Alex. Good morning. So my name is Dipankar. I'm a developer advocate here at Dremio as well, and I focus on open source projects like Iceberg. Today we are here to demystify Iceberg.
Exactly.
Right.
I think that's my big focus. I see a lot of conversations about various kind of topics in the area, like what's Iceberg, what are all these things. So really, before going into the deep philosophical, how you should set up your data type questions, let's just give everyone the quick answer, which is like, what is Apache Iceberg, and why are people using it?
Okay, I can I can get started, and then Alex can add to it as well. Yeah. So yeah, I mean, the data world obviously has seen a lot of turns and turmoils. Starting from the start of like data warehouses and then data lakes, and now with a lakehouse architecture. So basically, Iceberg is, in simple term, it's a table format that's sitting on top of the files on a data lake. So, for example, all these data files that you ingest into your data lake, like Parquet or CSV or whatever file format they are just file formats. You just need to be able to have a schema around those file formats. And if you are able to define a schema around those file formats, it kind of gives you that ability to like bring in different compute engines to that particular data. And that way, what you're making is your data architecture is basically storing data in open table formats like Iceberg and like the file formats like Parquet. So that means you are not limiting your data to any kind of just one particular store compute engine as such. So what happened here is instead of like having a one single unified system where you have different like the storage, the file format, the table format in one particular system where only one compute engine can access the data, now you have you can bring, depending on your work cases, like whether it's streaming, whether it's machine learning, whether it's BI, you can really plug in any kind of, so you're bringing the engines to the data, which is sitting in a quite an independent and like an open architecture. Alex, you feel free to add to that.
Yeah, the only thing I want to add to that is just that it's basically the key piece that answers one of the two major problems we have in data today. And those two major problems are well, it's all scaling, but one is scaling technologically in the sense that there's a lot of great tools, but no tool really serves all purposes. And that's the problem. You get stuck in these platforms. They serve a lot of great use cases, but then you have 2 or 3 use cases, and then you have to make 2 copies of the data in 2 different places to cover all use cases. So that bringing your data to the tools, as Dipankar said, by having a table format that makes it easy for any tool to serve the use cases where it serves well on the same data without having to make multiple copies of it is transformational. And that second problem being sort of the cultural scaling, in the sense that how do you, as an enterprise grows and you have different, and the data expands and the context of that data expands, how do you manage that? And that's sort of where data mesh comes in. So data mesh and data lakehouses solve sort of those 2 major scaling issues that we see in modern data.
Yeah, I think that's interesting because there's often this discussion of, like, for example, Snowflake versus Databricks, or adding another Presto, Trino, Dremio, etc. And one thing that I've seen that's very common for a lot of companies is like they'll have like 1 or 2 or 3 of these solutions for different tasks, right? Like one will be like, oh, this is data science workflows.
Right.
Use this engine. It's either cheaper or it's more built for data science. Oh, data engineering, we like this other solution because we feel like, maybe it has these functionality that we like. And I was actually talking to like a director of data at a large company about that, and they're like, yeah, it's funny, right? He's like, that's they try to sell us one or the other, but we really end up just using both. So it sounds like one of the benefits of Apache Iceberg is you don't have to really pick. You can kind of be like, okay, here's the data, and then we can kind of run what we need on top of it. Is that how you guys are seeing it used in most of your use cases for the most part?
I think that's like the major appeal in the sense, because basically the use cases are expanding faster than most platforms can add functionality. So it's a must to have to kind of run multiple tools nowadays. Like, so most people do want to do that because they don't want to be locked in, and also for that, because basically if you have multiple options, you're not going to get necessarily see the price creep that occurs when you do have lock-in. But also it's just you do oftentimes do need multiple tools, and you can simplify a lot of those pipelines if you're not having to duplicate the data. So I do think that's a very big selling point for a lot of people who are adopting Apache Iceberg.
Yeah. Do you know anything like what's the background on Apache Iceberg? Like where'd it come from? Why are people, basically where'd it come from is where I'm asking.
Yeah. So I mean, the OG or original problem that it was solving was sort of different issues that you had with the Hive table format. So to go way back, let's go all the way. Let's paint the whole picture. We go back to the world where data lakes first start up, and you have Hadoop, and then Hadoop has like MapReduce, and you have to write these Java-based jobs that were tricky to write, and they would have to write the disk after every job, and it wasn't necessarily the most performant thing. So then, and then yet people didn't want to write that Java, so you create Hive, and Hive lets you write SQL that gets transformed into that MapReduce job. But in order to have SQL, you kind of need to know what's a table. So basically, Hive had to come up with a way to say this thing is a table. So it came up with the format of saying, okay, this directory is a table. And then you had the Hive metastore that would track, okay, hey, this folder is a table and these subfolders are the partitions. And that worked. That was great, especially for like read-only use cases. But you still had times where you wanted to make more granular updates to a table, which didn't handle well, because basically you'd have to kind of replace a partition to edit even like one record. Yes. You'd have like stale stats, because you'd have to like manually run and collect stats on the table every periodically. You had slower queries because of like listing operations. So there's all these different issues. And Netflix was kind of running into these frictions. Over there in Netflix, you had people like Ryan Blue and the others who are all at Tabular now. Basically, they said, okay, hey, we have this problem we need to fix in order to handle the data that we have at Netflix. And they started working on Apache Iceberg. And then other companies like Apple, like Dremio and whatnot, all started contributing to the project as it became open source. And that's basically Iceberg solved those types of problems and created whole new types of functionality like partition evolution, made them available to data on the data lake.
Yeah. As someone who worked at Facebook with Hive pretty frequently, at least like Hive tables. Yeah, it's always funny. You're like, wait, I can't update this thing. I have to like just rewrite it all over again. That doesn't make sense. And then when you start talking about data modeling, like most people are like, oh yeah, you do like maybe slowly changing DIMs or something like that. It's like, no, you just do a different partition for every day, and that's going to be your various kind of like layers on how this data looks like. So exactly. It's always interesting when you realize like, yeah, it's just files underneath. So tables are kind of a weird construct. Do you see a lot of people who maybe were ex-Hive having a hard time switching over, or do you feel like it's pretty easy for most people to switch over?
As far as like the migration paths when it comes to Apache Iceberg, they're pretty, especially for Hive, they're pretty solid. Like built into the Spark procedures for Apache Iceberg, you have the migrate command, which was specifically made for Hive tables. So literally just with a quick call procedure in Spark, you have your Hive table become a Iceberg table. And then if it's just Parquet files or some other format, then there's the add files procedure that makes that pretty easy as well. So the migration path is usually, the mechanically at least, is easy. It's always like sort of like more the cultural shift of getting everyone to use to like, hey, you need to query the table here now versus the table over here, and making sure they're in sync in the way there.
Yeah.
Right.
Have you guys seen any specific use cases that you really would share with people that you think make it a good, like, make it clear why you should almost switch if you are thinking about it?
Yes. There was a recent conversation I had where a company, what they were doing is that they had a lot of little small tables that were broken up from one large table, because they had like a lot of little customers that needed a little piece of the data. So they were manually making all these small tables. And at first the conversation was, hey, should we make these tables Iceberg tables? That doesn't necessarily make so much sense, because Iceberg really pays off the larger the data set. But the more we started kind of digging into their situation, we realized really these are just partitions. Like each customer is just a partition of the table. So instead of them having to create all these manual tables to facilitate this workflow, they could just create one large table and partition it And then the way Apache Iceberg works will allow those performant queries, allow all the customers to only access the data they need via Iceberg's partitioning features. So basically allowed them to possibly eliminate huge chunks of workflows from having to create and validate all these derivative tables.
Yeah. And since both of you work at Dremio, like what exactly, where's Dremio fit in all of this?
I'll let you go on that one.
Yeah. So yeah, I mean, in the overall architecture of this data lake and lake houses, whatever you want to call it, basically you have like I said, the storage, right, where your data is getting stored, and on top of that you have the file formats that are landing, and just on top of that we have the table format, like the Iceberg coming in, managing all those things. So because the data is in such an architecture, you can really bring like any compute that I want. And like, for example, like, Dremio is like really utilized for like, kind of like the ETL workloads or like any kind of like ad hoc queries and those kind of thing. So you can plug in Dremio to that particular way. And to be honest, like if you really want a like easy way to get started around like Iceberg, and like, for example, if you have a CSV file or a JSON file and you just want to like create an Iceberg table using that, it's just a matter of like using a SQL query around that. So really, it fits in the architecture where you, and again, like Iceberg really opens up like different workloads for different kind of like analytical use cases. So you have large ETL, like distributed ETL kind of workloads. Sparks fits there. Dremio can work simultaneously at the same time. So we are not replacing anything around that. The whole idea is that even you're kind of like designing your architecture for the future. So you are not limiting any kind of future workloads. So for example, tomorrow I need to bring in like TensorFlow or like PyTorch into my like machine learning based workload as I mature my analytical journey. I can just plug in that particular way. And similarly, like with any other compute engine, Dremio fits in that similar picture, right?
Yep. And just to kind of add on that, just to kind of like in painting like sort of the big picture of where Dremio sort of falls into things. Dremio is for anyone with a data lake or wants a data lake house. Bottom line, it provides really three really big values. It's going to make things easier. So bottom line, if you're an end user who's interfacing with Dremio, it's going to be a lot easier to see all your data sources, interact with them. But if you're the data engineer, it's also going to be easier for you to connect all those data sources, curate views, accelerate those views. So you have that easy aspect. It's open. So you have all sorts of different ways you can connect to Dremio, whether it's data connecting in or data coming out, whether it's like through Aerofly, JDBC, ODBC. And it's fast. Basically, there's a lot of levers for how Dremio makes things fast, but that fast level also makes it affordable. There's companies that save like 80% in their cloud costs because we are handling caching and preventing, basically limiting the access costs on their S3, limiting their storage costs on their S3, limiting their compute costs on S3 through a lot of the optimizations that Dremio has. So Dremio just makes data lakes more feasible, better, and faster.
Yeah, that makes sense. Are you seeing like, because you brought up, I think, data lakes, data lake houses, are you seeing a lot of people switch to the data lake house architecture, or how do you feel kind of that concept is kind of fitting into all of this?
I think we're in the early stages. Like I would say, like 2021 was a lot of people exploring the idea of the data lakehouse, saying, okay, hey, what are the pieces? Let me run these internal benchmarks. Let me see if this makes sense. I think most people now are sold on this is sort of where things are going because they're realizing I do need more tools. I don't want to. Duplicating all this data is really expensive. So people are starting to implement data lakehouse. I still think we're in the early stages of those implementations. So basically, you see a lot of like, hey, I got a data warehouse and a data lakehouse. It's sort of in its infancy situation kind of right now. But I would say probably over the next couple of years, you're going to start seeing that data lakehouse at many people's at their firm start becoming a larger piece. And basically, you're seeing that because all the data warehouses are now trying to see how do I fit into that data lakehouse story, and that's I think a telling sign that basically everyone realizes this is where things are going.
Yeah, and one thing to add around that is that one of the things that I have realized, like speaking with the customers in general, is that the usual move, like easy move, like to migrate the workloads from like a data lake environment. The next move would be like a data lakehouse environment. And even with like warehouses now that we have started seeing support for Iceberg, like for example, like any kind of like cloud data warehouses, for example. So that means we are giving leverage to our customers now to own that data that they really should have the control on, right? Your own S3 bucket that you own, your own like environment and table format that you own. So you can really plug in the compute part again comes from the warehouse now in that way. So in a way, like the usual move is that from the data lake to the lake house, but also like a simultaneous move that we're seeing is from a warehouse to like a lake house environment as well.
Okay, yeah, that makes sense. Are there challenges you're seeing people kind of run into as they try to like take on a new concept? Because like again, it's one of the things where you're like, what is the difference? You're always like, kind of feels somewhat like a data lake. Again, it is supposed to be this hybrid, but like,
Yeah.
I imagine that causes challenges if people are trying to mentally even understand what it is.
Right.
Yeah, I think the biggest challenge right now are a couple different levels. Like one, just like figuring out how, like I think on the read side of Iceberg, you can read Iceberg from so many different tools. One of the things with Iceberg is that in order to see all your tables, you need to use a catalog. So a lot of the ETL tools that now have support for Iceberg, or different engines have support for Iceberg, they have differing support for different catalogs. So it's always like there's like this exploration where you have to figure out, okay, I want to ingest data into Iceberg. Which tool am I going to use, and does it interface with the catalog that I've chosen for my particular implementation? And also, just in general, everyone's still sort of exploring like their different options in the sense that people are still doing like internal tests between Hoodie, Delta, and Iceberg. So I think the challenges are people are just still like seeing how things play out and not stepping too hard in any direction yet. Although I would say I'm seeing a lot more commitment to Iceberg than I think a lot of people realize. But I would say like those are some of the challenges that I see just sort of like as people try to architect their particular implementation.
Yeah, I was gonna say I accidentally didn't mean to do this, but we're doing our live right now, and in 30 or 45 minutes, I think Joe is doing a live with Brian on the exact same topic. I was like, I did not mean this. I don't know how this all happened,
Right.
but we're all talking about Apache Iceberg today. So
Nice.
there's a lot of there's a lot of conversations about Apache Iceberg this morning. So that's pretty funny. So yeah, I think at the very least, it's always hard, I think, in the data space to tell what's going on and what's marketing, right?
Yeah.
And for better or for worse, like I think we all play a role in that for various reasons. Some of us just like certain tools, so we talk about it more. So I think I don't know. Maybe on that topic, is there any recommendations you have for people coming in trying to figure out like what's actually working, what's hype, what's all those different kind of things that are floating around?
Yeah. I'll let you hit it first.
Yeah, I mean, I think the whole industry in general is like, it's all about like now new tools, and we are trying to basically use different tools and invent new tools to like solve the new problems, right? So I think the whole idea, and people specifically for beginners like who are just getting started. I think I mean, for example, like I have been here in this industry for a decade now. Like even it's like a lot of tall for me like to just get started and like to understand what's happening. Like for example, like for me, like personally, if I think like, okay, I talk about lake houses or like table formats in general every day, but still people have questions around what is lake house. Because like the basic idea, I guess, is sometimes can be very confusing. Like because we have like invented so many new things in between and also decided like not to go with a certain way of doing things. For example, like we are calling like the end of the big data world, and there are different things around that, and there are like there are different ways to solve different problems now. For example, like, and those are valid reasons. So I guess the whole landscape is kind of like confusing as well. So I can totally understand that part. So in general, for me, like for what I say to people who are getting started with this space is that if you are coming from a world which is like you have worked in like databases and data warehouses, to be honest, there is nothing new in this particular. I mean, it's pretty much the same thing. It's just the way we have been working with data. Like I said, like in the previous world, like we used to have a table format. Like any kind of cloud data warehouse has a table format on their own. It's just that the table format is proprietary, like it's only internal to their own and optimized for their own compute engine. Whereas for like things like Iceberg, it goes beyond that, right? It's more of like a it's a set of APIs, right? Ultimately, technically, if I break it down, what Iceberg is, it's a set of APIs, and what it allows compute engines like Spark or Dremio or Trino to do is it's the responsibility of the engine to implement those APIs. So it's just a specification that is being laid out. So I guess that I try to like go back to the core of it, which is like, okay, these are just a set of APIs. You as a computer engine have to implement it. So I think, yeah, I mean, and again, Alex, feel free to add to that, and how the landscape has been changing in general. Yeah.
I agree. Like there's a lot of terms, but at the end of the day, like we're trying to do the same thing that we've always been trying to do. You want your data stored in the most optimal way, in the cheapest place to store it. And you want your compute to be as easy, fast, and cheap, whatever this is the best balance of those three things. And bottom line is like data lakehouse is just basically separating, saying, hey, the vendor that handles the storage doesn't have to be the same vendor that handles the compute. But at the end of the day, we're still searching for that same thing. And I think Iceberg really plays as a connector, or just the table format category as a whole really revolutionizes the possibility of just saying to say, okay, hey, here's my data. here's my compute. It doesn't have to be all in the same place, which allows, for me to maybe say, hey, I'm willing to spend a little bit more on compute here, but I'd rather spend less on storage here and not have to sit there and say I have to spend more on both.
Yeah, that does make sense. I think what's kind of an interesting thought there is like earlier you referenced, you get that trade-off of, oh, I can now run any compute on top of this data. I don't have to be stuck on one thing.
Right.
Do you also feel like some people maybe end up feeling like they create a more complicated system? Because again, now they've got things kind of separated, right? Like when you have a nice product, like, insert product name that does both storage and compute, right? Like you don't have to think about anything. It's like, okay, it's all there. I don't have to think about how things are being run. But do you feel like people have to take more on in this new paradigm?
There's certainly a trade-off.
Yeah.
I think this is like, where, platforms like Dremio do play a big role in the sense of just, it makes it feel more like a traditional sort of, hey, you have everything in one box kind of feel, give that sort of intuitive UI. But bottom line is like, basically when you're using a platform like, your favorite data warehouse or other platform that kind of gives you everything in one package, it is easier. But again, use cases are expanding faster than any of these platforms can really add features for. So basically the trade-off is like, if I'm willing to sacrifice those extra use cases, I get this nice little box. And if I'm willing to pay a little bit more, I get this nice little box. But if I can, and then, the money you can save potentially is not insignificant. We're, talking about tens of % of your costs, especially when we have an economy like we have one today, where basically, where you had high interest rates and basically capital was, starting to look like it could have been scarce and whatnot. You have to start thinking about, okay, is this maybe nice abstraction worth sort of the cost of this capital that I might need to make sure I have a bigger runway as X company or whatnot. So I think that trade-off is much more on the cost side now, which is why I think data lakehouses are being looked at a lot more now, because there are a lot of avenues. But right now, I think there is a trade-off of convenience. I think there's many platforms that help reduce that cost. I think Dremio is a key one that really reduces some of that sort of cost of inconvenience, making it a lot easier to use. But there is sort of that initial, the implementation though is a little bit of a trade-off versus just turning on a data warehouse.
Yeah.
One thing I would like to add to that is that the size and the scale of the organization getting started with the analytical journey is also like another perspective towards it. So for example, like a smaller company, maybe they're just getting started with the analytical journey, and they might just need is just a simple cloud warehouse to get started and like not piece around different technological piece around here, or and as you grow with that scale, you might need to think about different option and balancing your cost option, like Alex was mentioning as well. So the trade-off is like, okay, now I'm a more like a more a mature organization. I need to have control on the data and my storage cost and everything. So that's where I'm ready to make that trade-off and go with like more of a this kind of architecture, like two-tier architecture stuff. So I think that's another perspective towards it. Like, that you kind of get from the customer angle as well.
Yeah. I think something that maybe we haven't talked on, but for some reason you just made me think of. I think I'm talking to especially larger companies, and there's this discussion of bringing data back, right? Or bringing stuff back to on-prem, right?
Right.
And running things yourself, or trying to see if you can make it cheaper rather than like running it, in the cloud for various reasons, right? Especially once your data actually gets really big, suddenly something like Snowflake, it's like, is it going to be that cheap? Is it really, So are you guys seeing anything like that? Like where you're seeing people try to figure out, like, can we do this on-prem plus maybe some cloud where we need to do cloud? Is that another reason for data lakehouse to kind of exist or something similar? Because as people are trying to figure out how to keep costs low and run the right workloads in the right spot.
Yeah, I mean, I personally haven't had like that particular conversation yet, but I don't talk to necessarily everyone about that sort of like reverse migration story. But it makes sense because again, when you're using some of these platforms, like the way they're set up, especially like you hear like a lot of this discussion of sort of like the cost of like ELT. So basically, if you just transport all your data, normalized into like a data warehouse, you're paying for a lot more storage, and then you're paying a lot more for your compute to then run all your joins there and whatnot. And then basically, you may have the benefits of the cloud, but you're wasting a lot of those benefits and the extra cost. Well, but I do think there's patterns where you can have ELT and it can be practical, it can be affordable in the cloud. It's just that like it depends where you're landing the data. This is where a lakehouse makes a lot of sense, because if you take that ELT approach and say instead of landing it in where it's more expensive storage, you land it where there's cheaper storage and you use cheaper compute options, then that do a lot less processing. It makes more sense. But Yeah, and then whether people move on-prem to save money, or they explore a data lakehouse to save money in the cloud, or a data lakehouse on-prem to save money in the cloud, then you want a platform that can handle both.
Yeah.
So that's one of the sort of the unique spots of Dremio in the sense that it can handle cloud and on-prem. But I do think cost is an issue, and I do think people are exploring like, hey, does the promise of cloud have the same promise as it did? And it really just depends on the platform and architecture you choose. There are ways to make cloud affordable, and there's ways to make on-prem affordable. But again, with on-prem, you are maintaining that infrastructure, and there's sort of like, and then you're right now you're locked. If you're on-prem, you are locked out of a lot of tools that are cloud only right now.
Yeah, I think another kind of thing that's or undercurrent that you guys are referencing a lot is kind of this push for cheaper infrastructure or cost savings. I think that's funny to me because it's one of I feel like the cycles that we go through in the data world, and maybe the cycle is driven purely by interest. I don't know, but right, like first, everyone's on like Teradata and like all these expensive solutions. Like everyone's like, oh, data's big, expensive. Okay, everyone goes to Hadoop because like in theory it's cheaper in terms of like solutions cost, but then like, oh, we need really smart people to set this up, and that's really expensive and time consuming. Okay, Snowflake and Databricks, this sounds great, and now it feels like we're kind of like Snowflake. I think Snowflake and Databricks are aware of this, so they're trying to like get ahead of this as well. But like, it's like everyone's like, can we find something cheaper? What can we do? It always feels like there's a trade-off in terms of like, well, now we need to think about things more. So I'm just curious, do you feel like you see is that some sort of loop you're seeing? Are we just stuck in these cycles forever?
Yeah, definitely. Yeah, that's a pattern. Yeah, that's for sure. Yeah, and to be honest, like even in my career, like I have seen like come from a similar background. Like started with like Teradata, worked in some kind of a, like on-prem warehouse, switched to Hive and Hadoop, and like just to simplify cost and that way. But then we had this additional cost, which is not monetary cost. So it's really an effort to like run and maintain those MapReduce job and stuff. So and now that we are like, okay, we have a way to easily start up a warehouse and like do our analytical stuff, and that definitely those much easier. But now that we're like kind of talking with more on people around those costs and like those the vendor lock-in and perspectives, I think that's kind of the blocker for like people who are like really who really wants to like mature their analytical journey, right? For example, like you just don't want, like today as an organization, maybe you started with your like reporting and stuff, but eventually maybe you want to, or you may have, you'll most possibly have some kind of a workload that's different to that. So how do you accommodate these different workloads without really changing much of your architecture, right? That's the whole pain point, because with that changing architecture, you are going to involve like a talented set of engineers in that. You need to have cost involved, different architecture, different cloud technologies. So these different things ultimately add up, and what people are trying to solve, understand now how they can get rid of those kind of vendor lock-in and lower cost and stuff. So I think that pattern is kind of repeating right now. I mean, the only positive aspect that I see right now that's kind of different is that now we have an abstraction on top of that. Now we don't need to run kind of MapReduce job to do that, right? Now we are able to do those push downs and those kind of things with this compute engines. So yeah.
And just to add to that, like I do think like this goes for like pretty much any trend in the world. We go through cycles. You kind of go pendulum between sort of 2 points, but every time the pendulum swings, it doesn't swing all the way back. So even though like, hey, it looks like we went from, like you said, like the on-prem data warehouses to data lakes and then back to sort of cloud data warehouses. Once we get to cloud data warehouse, it's still not like exactly the same as far as the cost and inconvenience of that. And then we get to data lake houses, it's not quite the same inconvenience and cost as a data lake. So it's always a better swing thing. So overall, like the trend is positive, but yeah, we're going to constantly have these swings. So, which is probably why like hybrid mix and having a little foot in both ways is is probably going to be an inevitability.
Yeah.
It's funny. I've talked to a few companies who have like Teradata and Snowflake, and they're like, yeah, well, Teradata is like cheaper for some things, Snowflake's cheaper for other things.
Right.
It's interesting how you're kind of seeing all of this. I think another interesting space for both of you guys is careers, just because you guys have both worked in the space for a while. You guys now kind of work in an interesting space, right? Like you're both in DevRel, so that's kind of like. I'm just curious, like, is that something you're seeing more people kind of come into, and why? Like, why is this kind of space kind of growing?
Yeah, I think it is growing. It's growing because it's because at the end of the day, like your decision makers are oftentimes you need like evangelists who are like technical. and you need people who can talk to those technical people.
Mm.
So I think the demand for dev role and the demand for developer advocates is growing. I think filling those positions isn't as easy as it like, because it does require sort of a unique set of skills, like in the sense of being able to articulate the technical side of things, and then also be able to you know understand the technical side of things. And oftentimes you don't see those necessarily in a nice tidy bow. Before I went into technology, I worked as a trainer in finance for 10 years, where I would just train people at all different levels on getting their financial licensing, on stocks, bonds, stuff like that. So I had a long time of just talking and breaking down complex ideas that really lent really well to when I decided to explore this side of the industry. But it's tough to kind of find that balance and to find people who kind of have enough exposure on both sides of communications and technology to fill these roles. So it's interesting to see sort of like the demand and the pace at which these roles get filled.
Right. And just from my career perspective, like I started as a software engineer, like, back when I graduated school. Then I went to different roles like BI, data science. I went as 2 years for my visualization research as well. And then the whole point of this was that, like, there is a community aspect towards it. And that's kind of the driving force. Getting the opportunity to work in like open source solution like this is usually typically tough unless and until you are like code contributions or those kind of contributions, right? So I think that's the whole point of it. And now that we're like, to be honest, Devrel has been there for like years now, like started from like back in like Slack and Twilio and like Microsoft and Apple, right? How they were focusing and targeting this different product for different developers, right? So I think now in the data world, we are changing, kind of seeing that move, and we are seeing different people like from data engineering, data science background move to a DevRel role. The idea is that these are the people who have seen those pain points. These are the people who understand how really, a certain technological problem is framed in front of the world. We have been talking about lakehouses in general, and I don't know how much we have been able to like, demystify it. But the whole point is that we should be able to, be in their shoes and the shoes of the developer and be able to explain those concepts or write that code in a most easiest way and the most scalable way as possible. So I think that's the whole reason that now we're kind of seeing that kind of jump.
Yeah, I think it's always interesting, again, just all these trends and all the ways that people are trying to help make it clear kind of what's going on, I think, in the data world. And so one, appreciate that from you guys. I guess in terms of like picking up skill sets, whether it's DevRel or learning Iceberg, do you guys have any things that you guys do to try to like keep up with everything that's going on in the data world?
I listen to a lot of podcasts. And that's the same thing when I was on the website of the tech industry. I would just listen to a lot, and I still listen to a lot of what podcasts and data and web. It's always just kind of be up on what's the newest frameworks, what the newest tech. Watching a lot of a lot of videos on YouTube to kind of see like what people have to say about it, but also just getting hands on. Like basically for me and Dipankar, I can assure you, like the last couple of years was just a lot of just sitting down with Spark, Flink, Iceberg, Dremio, and just running all sorts of different types of like workflows. And that really, at the end of the day, just getting your hands dirty is the best way to feel. So every time I hear about something new, I try to get my hands on it and play with it a little bit, or at minimum try to watch a video of someone else doing so, just so that way I see the big picture and I kind of understand the context of what it is, and also understand sort of like how difficult it is to get set up. Because a lot of times, like, that is where the biggest pain points are, not necessarily in doing the thing, is setting up yourself to do the thing. And that's where, like, I feel like we play a largest role in helping people learn how to get set up so that way they can evaluate Iceberg. Because, like, okay, well, how do I set up this Docker container to do X, Y, and Z?
Yeah. It's pretty much the same thing that I echo. Like, getting hands-on is one of the things that, like, I have always tried, like, and we have always tried, and like, that's the main thing. There are gonna be like a lot of new tech and new jargons in the industry in general, in the coming times as well. It's just a matter of going to the core, understanding the core concepts, and like trying to implement that in your own way. And you don't have to reinvent something to do that nowadays. Everything is like simple abstractions. So it's a matter of like how you take that and apply it in your own way. Like, there's so many projects and ideas in general. Like, Ben, for example, you share so many project ideas. Like, it might be a good idea to even take something like that's happening in the data lake world and see if you can like implement Iceberg on top of that. And it sounds like might be daunting at the first time, but it's not even that complicated for like a programmer, like a data engineer in general.
Yeah. I think that just going back to like the 2010s, 2015, and if you're like, I want to learn Hadoop, and it's just like, Well, let's
So
get
many
started.
things.
So you're gonna spend the first like week just figuring out how to get it working on your computer, making sure
Setting up the
all the
cluster.
yeah.
Yeah.
So they're
Yeah.
like, and
Yeah.
it even conceptually, it's like, what do you mean? Like, what am I setting up? Where is it
Right.
going?
Right. Right.
And of course now it's like, I'll just spin up something on AWS and you're good if that's what you want to spin up.
Right.
So that's it's a very funny kind of world that we definitely have
Yeah.
shifted to. I think there's a few questions. Like I don't know if you guys are hoping to a few questions, but I think I'm at least interested in this one, which someone's asking in terms of one big table design with Iceberg as opposed to traditional star schema. Do you guys have a way you recommend people model their data in Apache Iceberg?
Not necessarily. I mean, either will work. I mean, I don't think Iceberg is like saying, hey, it has to be one big table or you can't do a star schema. It depends on the size and scale of the data. I mean, Iceberg just makes it much more practical to do it on the data lake. So whether you're doing a star schema or you're doing one big table, like how you're gonna be able to how you're gonna be able to evolve that table when it's existing as a bunch of Parquet files in your data lake is gonna be much easier when you're using a table format like Iceberg versus just a bunch of Parquet files or using a Hive table or something like that. So I don't think it's Iceberg's architecture is necessarily out to make those kind of decisions for people.
Yeah.
Yep.
Yeah. I think I just recently saw someone kind of point like on LinkedIn kind of say like, oh yeah, like everything should just be one big table. And I was kind of like, I mean,
Yeah.
I get where you're coming from. I think
Right.
a lot of things, like for anyone out there, I think a lot of things sometimes end up in one big table, but there's
Yeah.
always pros and cons to everything. So I'm always curious on like what other people feel like, because I'm like I maybe I just have a hard time being like not dogmatic, but like very like this is the only way kind of mentality.
Yeah.
Like there's so many ways. Let's see. I think this answer is pretty straightforward. But someone asked, can we insert data in Iceberg without Spark? They want a DuckDB.
Yeah. So I mean, there's like I said, like the support for like different engines are coming out with different support for Iceberg. Like I think right now I don't think we can do write operations in DuckDB. I think there are plans to. I see some PR. I saw some PR recently that plans to do some more integration. But the ideal first step, like for engines like who are just getting started with Iceberg, is like to read the data. So that is an ideal case. But there are a lot of other engines like Spark or even like Iceberg, like the Python word, like API of Iceberg is something that is super easy to get started with, and probably you can't write that scale of data right now, but you can at least like create your table and do a basic read operations, scanning this table and stuff. And internally, actually, you can, if you scan Iceberg table using Python, if you're familiar with the language, you can actually convert that particular table object to like a PyArrow or like a a pandas or a DuckDB object, and then you can run your analytics from there.
Yep, and then just like kind of add to that, because right now Pi Iceberg supports the certain catalogs. So right now it's like REST, AWS. I think it just added DynamoDB catalog to the Pi Iceberg library. But let's say you're using other catalogs like let's say like a Nessie catalog. What I did, I created a library in Python called Dremio Simple Query. So basically, if you had like a Nessie catalog connected to your Dremio, or really literally any data connected to Dremio, you could pull it through and then feed it into a DuckDB relation. So that way you can do ad hoc queries with DuckDB on any data you have accessible to Dremio.
Makes sense. Someone was asking about like kind of Delta versus Iceberg, but then someone also asked this other question in terms of Delta. So maybe we can do a little bit of both, like Delta versus Iceberg. One, what's the difference, but also something we can then dive into this question afterwards.
I can start with it, and then Alex, you can probably go a bit deeper on that.
Yeah.
So I think the question is around uniform or uniformat, which is like a recent database announcement around like how they can convert. Basically, everything is around Parquet, and a layer on top of that, you can convert that, and you can use whatever their engine is. We still have to understand the technicalities of it and how easier and how I would say how like swifter it is to like migrate those kind of workload. And I haven't read much around that, but I do understand that there are like these different table formats have different way to like convert even from like Delta to Iceberg or Iceberg to Delta. So I think it's not a question of like people leaving something or people adopting something. Ultimately, the whole point is that if your architecture has something that you have adopted like Iceberg, it's not just like the performance, or it's not just about one particular area of it, right? There are different perspectives about it. Like for example, like the the truly open source nature of Iceberg is something that is often like, we talk about the technical problems of things, but the open source part of it is like really something that's driving. It's a really open table format. We are able to understand the different features and capabilities. So the driving force is towards that. So that is around my my two cents around like community and in general why like people are like not leaving a table format for something else. But in terms of technicality, Alex, you want to add something around that?
Well, yeah, I have a lot to say on this topic. But okay, so bottom line is I do think that the future is developing some sort of interop feature. The model I think that will eventually win will one have to be one an agnostic project that is not run by any of the three formats or work in collaboration of three formats. And two, it's going to work more like the mitosis project that Builder.io does, where instead of, because right now with like Delta, and I'm not sure what OneTable doing was. So OneTable is sort of the effort coming out of OneHouse, which is are on more in the hoodie camp. And then you have this uniformat coming from the Delta side. So both efforts for interop. But I know like the Delta format, the Delta uniform, what it's doing is writing a second set of metadata. And it's actually doing it asynchronously. So if you had multiple writes going into your Delta Lake table, it would batch those and just write to the Iceberg table. So you wouldn't necessarily get all the same commits that you have in your Delta table in your Iceberg table. So it limits what's possible time travel wise. There's possible inconsistency issues with the way it's currently implemented. So I don't necessarily. I'm glad that it's being developed. Like I'm glad any effort to make there to be interop between these formats is I applaud that. I do think the inevitable sort of like the thing that will be the tool that connects all the tools will be sort of an agnostic intermediate format. So the way mitosis works for Builder.io is that you don't convert, let's say, from the front end framework React directly to Vue. You convert to this intermediate JSON spec called mitosis, and then you convert to any of these other points. So that way you only have to write one converter that converts in and out of that format. And that I think would not only make it easier to convert between the three formats, but also make it possible for 4, 5, 6, a lot of maybe even specific use case type formats. Because I can't imagine a world where the metadata could be formatted in a particular way for a very specific use case, but it wouldn't make sense for a general use case format like the three we have now.
Yeah, that makes sense. And in terms of everyone trying to be the VHS standard, but like in this case, like the translator of like VHS and Betamax, and like the middle ground. It's like, how do we create that? That's kind of interesting. What am I trying? Overall, I guess how like if you'd recommend like more just again focus on Apache Iceberg and everything that's going on, how do you recommend people try to just get an understanding of it? Because it is this extra layer. Do you guys have certain things you've read that helped you get up to speed? Have you guys written anything that you think gets people up to speed pretty quick?
I think there's a lot more available now than there was when we both first started. But I mean, two places that I would point to is one, I wrote a blog called Apache Iceberg 101. And not only does it have a link to a video series I did that kind of goes through all the concepts, but it also has a link to pretty much all the blogs around the web on different topics and organized. So that way, if you're looking, hey, I'm trying to look for a blog on streaming, or I'm looking for a blog on this specific use case, it's all categorized and organized for you in that article. And then two, I'm trying to quarterly create a new Iceberg overview video where I do that high level overview, but with any updates that occurred. So I'll be doing another one sometime in August. That'll be on the Dremio YouTube channel. So subscribe.
Nice. Good.
Yeah, sorry about that. Yeah. And we are also writing the first book. So it's on an early release program. And that means we are writing out the chapters and publishing it as we write. So, that might be a good idea. So that way we can also collect feedback from people like, who are really like-minded and, interested in general. And that way we can make the book more better as we publish towards the end of the year. Yeah.
Yeah. And I think I linked that on the YouTube side. So if anyone wants to find that, it should be there, I hope.
Cool.
Yeah. So you brought up updates. So that makes me curious, like what updates were the most recent stuff coming out of Apache Iceberg that you were really excited about?
Yeah. I think in general, in the last, like the 1.3 release, a couple of interesting things, for example, like the native ability to understand like CDC, right? Ability to like monitor a table and, understand those changes and push downstream. So that was something that was pretty interesting. We have a new branch and tagging capability natively within Iceberg now. So that means you can do things like you can basically create your own isolated branch at a table level, and you can run, for example, like do your own isolated like ingestion in there without really impacting all the production workload. and from a table level perspective. So that gives you ability to do those kind of like experimentation and reproducibility and those kind of stuff. That is another interesting thing. We have a lot of improvements on the Spark side of like performance. Like for example, like AQE, right? Query optimization and those kind of stuff were recently added for things like updates and deletes and those kind of queries within Iceberg. So I think the performance angle of it has really improved a lot with the latest version. We also like always have had like the support for Flink, and now the Flink ecosystem is maturing with Iceberg. Like me and Alex have been working as well, like to bring up some Flink and Iceberg, like topics around that. We're working some around some blog. I think one blog is already out. So I think those are the kind of like things that are kind of really maturing in terms of the community, and that's super interesting to see.
Yeah, and on that, well, one I was point out that Flink blog. So yeah, we just published a Flink blog on, I think it was on last Friday. And if you've never used Flink and been dying to try out Flink, they kind of get it. It was written really like for anyone who hasn't ever used Flink before. But two, on that versioning piece, the versioning story for Iceberg is really interesting because it's the only format of the three formats that actually has three options that you can use together even for like basically in Iceberg you can do file level versioning with AKFS, you can do table level versioning natively, and you can do catalog level versioning with Nessie. So basically you can do that in Iceberg. Well, other formats, the only option is really file level format. So Iceberg gives you lots of options in that open architecture, and just want to kind of point that out.
Yeah. Someone has a kind of funny kind of too true comment on LinkedIn. With all the changes happening in Iceberg, a book is going to be active.
Well, Brian is right. Yeah, well, Brian is right.
Yeah. I mean, fortunately, like as we've been writing the book, there has been a lot of changes, but most of the changes with the Iceberg have been additive, not necessarily like changing what existed before, but adding new features. So it's expanded what we were writing in the book, but it hasn't necessarily changed so much of what we've written in the book. I think, the only thing that I can think of change, like there was some little changes, like some additional metadata tables, and I think there was a change to the schema of the entries metadata table, but that was happened before we wrote that section of the book. So that's all as it stands currently, and I don't foresee. Usually, the way I see the Iceberg changes is they're generally always either additive, they don't generally break the past changes. So like generally, the book should stay consistent.
And also we are covering the core concepts. So the whole idea, since this is the first book on Iceberg, the idea is to like people get the idea of the 4 core concepts and around the technologies around it. So it's going to be a lot of hands-on examples. For example, that's the core like aspect of this as well. So I think that is going to be the similar like part. That's going to be same.
Yeah. It's the challenge of writing a technical book. I'm trying to remember what someone told me. They're writing a book on like, I don't remember if it was like the thing before transformers, which I don't remember what that was, in terms of like in deep learning and neural networks. And they wrote like huge, a huge book on it. And then like that year Transformers came out.
Yeah.
Like,
it's
all
over,
of the stuff is pointless. No one's going to read this anymore because everyone's going to read, everything on this new thing. So that's really funny. Someone asks, are there any community-driven initiatives or extensions to Apache Iceberg that are worth exploring?
There's one in particular, and I already mentioned it's close to my heart, and that's Nessie. So Nessie is an open source project, and what it is. So going back to this, let's understand what a catalog is. So basically, again, for any engine to communicate with your Iceberg tables, it uses a catalog. So there's going to be some sort of mechanism that kind of lists out, hey, these are the tables that exist in my Iceberg world, and there's different tools you can use for that. And in the Iceberg world, there's 2 sort of open ways of, and again, open is always good because that means you're gonna have options. There's 2 catalogs. So there's Nessie, which is an open implementation. So in the sense, it's an actual catalog that you can see the code, you can go spin up and run and maintain on your own. But there's also services that provide a Nessie catalog as well. But what it does, it provides not just a catalog, but it provides catalog level versioning. Which means, hey, if I have 1,000 tables that I do bad ingestion on, or a failed ingestion job occurs on Friday, I don't have to roll back all those tables individually. I can roll back all those tables by rolling back the catalog back one commit. So that makes, or to the proper commit. So that is, I think, a big game changer, and also allows for things like multi-table transactions, isolation on branches, tagging at the catalog level. So instead of having to tag 100 tables individually, you just tag the whole catalog at a certain point, and you can reproduce that data. But also the other sort of open table is what's called the REST catalog, which is an open spec. So it's not an actual specific implementation,
Mm.
but a REST API spec that allows people to build their own implementations on. So even though Nessie also has its own open REST spec, so theoretically you could re-implement it, but the implementation's there. But basically you have these sort of two open options. So and that's really nice because again, not only is the project itself Iceberg open, but you have all these open initiatives within the Iceberg ecosystem.
Yeah. Cool. Well, we've got 9 more minutes left. So if anyone has more questions, please feel free to keep posting them. I think there's a lot of interesting things we've definitely kind of picked up here, and definitely I have as well. You've referenced Flink a few times, so I'm gonna at least poke at that. Like, how are you seeing people use Flink? I think in the real world, so people can kind of maybe get an idea of that. And what is it really for some maybe newer people to the data world?
Flink is a stream processing engine, and it's been there for a while. I think the community in general has seen a lot of use cases, for example, like Apple, for example, has been like, we know Apple because like they have Flink and Iceberg integration at a very larger scale. They have a lot of late coming data in general. So I think for beginners, Flink is a stream processing engine. So basically it runs batch and stream workloads, but optimized for mostly streaming workloads as well. So really, you can process data at streaming level as well. And how it integrates with Iceberg is another thing, is because you have your different streams that you're processing, and you're trying to basically get it into your own table format like Iceberg. That's kind of your sink, right? You have different terminologies to get into there. So what you're basically trying to achieve is that those streaming workloads, you're trying to okay, sorry, yeah. I think there was some network lag. So what it basically is trying to achieve is that Flink is trying to process the stream workloads and put it into like a table format like Iceberg, which basically enables you to do other kind of analytical workload. Like for example, you can really process the stream data using Flink, and you can run a compute like Spark simultaneously on that processed data once you have the data on Iceberg, right? So it kind of opens up a new avenue as well. So I think that's the whole point of that. And the idea with Flink is that I think personally, since I have started learning Flink, the whole the problem that I've seen is that the DevX kind of needed a lot of work. There are a lot of things to know that personally was for me a bit daunting. But now that's the whole point. We are trying to probably make that experience a bit easier, from an open source angle. Flink SQL is something that I personally recommend. That is super easy to get started. It's SQL derivatives, so it's super easy. But Alex recently worked on a Java sync, like he was mentioning before as well. So that also gives you an end-to-end flow. So there are different APIs to process different streaming data. Obviously, the Java and the data stream API of Flink gives you more flexibility around that.
Yeah.
Whereas Flink SQL is kind of more limited towards just reading and processing data.
Yeah, and just to kind of add to that, just the bottom line is Flink is part of one of the other major questions we constantly have in the data industry. Do I stream or do I batch? And you starting to see that streaming conversation coming up a lot more. I mean, you have Decodable, who's basically created a product around Flink. And but bottom line is whether you're talking about Kafka, you're talking about Flink, you have sources where the data's coming from, and you got sinks where you're sending the data to, and there is the ability to receive Iceberg data and send out Iceberg data on Flink. Just one of the challenges I say that exists nowadays with Iceberg is just that when you're trying to have performance streaming, the Iceberg spec has something called an equality delete, which is a version of its sort of delete files for merge on read type reads. Basically the support for different engines to read equality deletes is still expanding. So that's always a consideration. If I'm going to stream in my Iceberg data, make sure that the tools you either want to run compaction afterwards, so that way you clean up all those equality deletes, so that way your read tools can read it, depending on whether they can read equality deletes or not.
Okay, that makes sense. Yeah. Any thoughts on where batch and streaming is going?
It's use case driven. At the end of the day, if I have certain data and the sensitivity of the insights aren't, for example, if I'm talking about financial data or stock data, where you really do need real time data, then I'm going to want to stream as fast as I can. But if I have if I'm talking about sales data, where I'm fine just looking at the sales for the last week, possibly depending on sort of the rate of sales and the girth of our sales, then I'm going to spend a lot less money doing batch.
Right. I think one of the pain points that personally I have seen is that with streaming, even in my past organization, that whenever we were trying to deal with streaming, the infrastructure and the environment in general was so difficult at that point of time to set up. And now that we are seeing more of the streaming databases and streaming processing engine, for example, Rising Wave is an open source project that has a Rust implementation. And I know Decodable was doing stuff around simplifying Flink and stuff. So I think now, and there is Stream as well, so those are different companies. So I think now the idea is to make it a bit simpler and like help people like get started. So I think that's the kind of the pain problem is there.
Yeah. Rising Wave I've seen now come up a few different times. So I'm definitely going to have to dive more into that project. There's, again, I think we talked about this earlier, too many technologies to keep track of, too many things to be like what's going on in this data world.
Right.
Part of the reason we're doing this video, which is what is Apache Iceberg. And if anyone missed it, we answered that in like the first 5 minutes, so you don't even have to watch this whole video to answer that. But I think we've had a few different topics here that we've covered beyond that. You guys have referenced Dremio, which is great. Also, we've talked. What else? We referenced Nessie. What other topics did you guys enjoy kind of over this conversation?
I'm just talking about like Iceberg, the different use cases for Iceberg, versioning in Iceberg.
Yeah.
What about interoperability between the different table formats? It's been a great conversation.
Yeah, and cost and scalability is always like two of the main terms. Like for me, like to understand, like I always like try to understand and talk with the customers around that. So I think that's a really interesting topic as well. So
yeah, it's one of those things where it's like I think as a data person, maybe you don't start thinking about initially, right? Like when you're first, you're like you're all you first care about is like, oh, I need to learn SQL, I need to learn how to write Python or something like that.
Right.
But it's like inevitable as you like grow through your career, or maybe I think the one way I have heard people kind of worry about cost is like, oh, I'm scared to run a query.
Right.
Which to some degree is not a bad thing. I had a conversation with someone recently where it's like, yeah, if you came from the world where like, in the old days, it's like if you had a 2-hour long query, no big deal, right? Like it's one instance, maybe you've got to make sure that there's resources, but it doesn't mean anything because that server exists.
Right.
Nowadays, if you've got a 2-hour running Excel thing on Snowflake or data or whatever, it's like, oh, you just cost the company like
a hell lot of money.
So maybe there's a little more reason these days, but like I do know people who are like a little scared to run queries because they're like, oh, it's going to cost so much money. But besides that, I think a lot of people don't think about it. But as you get deeper in your career, you're like, okay, yeah, costs. You're like, why do I care about costs?
Right. And totally, absolutely. Like, that's how you like start exploring, like, and you get more like a senior, or like now with warehouses, like, and everything. Now we are like, oh, okay, am I really like I'm supposed to run that query? Should I ask someone to run that query? And those kind of things. Like, yeah,
that's funny. Cool. Well, I don't know. Do you guys have any final words before we kind of sign off? I don't want to keep you guys too long. So yeah.
Oh, I just want to say one, thank you for having us on the show. 2, do subscribe to the podcast. Me and Dipankar do Select Star from Data Lake. Also subscribe to Gnarly Data Waves, which is our weekly broadcast. Actually, tomorrow we're going to be talking about how Maersk saved a significant amount by adopting a data lake house. So make sure to subscribe on iTunes and Spotify, and follow me on LinkedIn.
Nice, Thank you so much for having us, and we try to like contribute stuff like for Iceberg or open source or in general whatever it is, and it'll be fun to like get any feedback and see how people are enjoying it or not enjoying it, whatever it is. So thank you so much for having us.
I appreciate both of your guys' time, and I don't know how you manage like 2 or 3 podcasts. Like I do this live once in a while. Occasionally I'll do 2 in a week, but then I'm like anything beyond 2 in a week, I'm like it's way too many. So no, I appreciate guys all the effort you guys are putting
of course
to keep the community informed. So thank y'all. Also thanks to everyone who listened. Other than that, if no one has any more questions, we can kind of sign off, and everyone can go on with their days.
All right. Thank you so much for joining.
Thank you all. And
all right.